Hello everyone, welcome back to Grade 10 Applied Math here with Mr. Stone. So this is Unit 3, Activity 5. We're going to go back to quadratics. Okay, so let's do a quick recap on what we've learned so far about quadratics. Remember, quadratics make a parabola, this sort of curved shape here. And this parabola has certain features, right? We have our vertex, where the function turns around. Here it's at 2, -1. We also have our axis of symmetry, sort of mirror that flips it. Then we have a minimum value, which is the y value of our vertex. Notice also the x value of the vertex is the axis of symmetry. And then we have our y-intercepts, where the line hits the y-axis, and our x-intercepts, where the line hits the y-axis, the x-axis, sorry. And notice that there's two. Because the curve turns around, we have two places where the line hits the x-axis. In this case, it was 1 and 3. Now, what's nice about this, well, we've seen some equations of parabolas based on the vertex, but there's another way we can write these parabolas, is what we call factored form, where the zeros are just the numbers that go into our equation. For example, here, the zeros are 1 and 3, but the equation ends up being y equals x minus 1 all multiplied by x minus 3. And we call this factored form, where the zeros are the numbers that go in. Oh, sorry, my pen isn't working. Anyways, 1 second. All right, so the zeros are just the numbers that go into our equation here, like this. This is called factored form. Let's do a quick example here. Let's say I have this parabola. The numbers are small here, but the x-intercepts are 4 and -2. So to write my equation, all I have to do is write out the general form that x minus s and x minus t is my equation. And if I replace s and t with -2 and 4, being careful that subtracting a negative all ends up becoming positive, I end up with x plus 2 and x minus 4. And that's my final answer to this equation. All the examples we're going to do is going to have a coefficient of 1 in the front. You can change your equation quite drastically by changing the number in front, but we're going to keep those as just 1 for our lesson here today. And notice now our our axis of symmetry, the mirror here, is going to go through 1. Right? This is x equals 1. Right? And notice that when we have our zeros of 4 and -2, they're both 3 units to the left and right of our y-intercept. It's in the middle. So if you know the zeros, if I know the zeros are -2 and 4, I can find out the axis of symmetry, by finding the middle of 2 and 4. And one of the ways you can do that, you can just add them up. So -2 plus 4, and then divide by 2. Find the average of the two numbers. So 4 minus 2, or -2 plus 4, that's going to be positive 2. 2 divided by 2 is 1. Okay, notice that's in the middle of our zeros. Or you can just do it on a number line like that. So, okay, I got -2, got 4. How do I go? So 1, 2, 3, 4. And I end up at positive 1. Okay? So it's in the middle. That's what the key thing I want you to keep in mind. The y-intercept is in the middle of our zeros. Let's do another one. Again, numbers are kind of small. That's a 2 and that's a -5. Okay, so zeros are -5 and 2. And I can replace that in our equation again, and I end up with x plus 5 and x minus 2. Keep that in mind, that the sign is different. So if you see this as x minus 5 plus 2, then the equation will be x plus 5, opposite sign, x minus 2. We change the signs on the inside of our bracket. The signs are always different. Keep that in mind, don't forget that. And then, again, our y-intercept now is going to be 1.5, which is a little bit trickier because it's in the middle of -5 and 2. Okay? And we can do that again. -5 plus 2 is going to equal to, what's that? That's going to be -3. And then if I divide both sides by 2, -3 divided by 2 is -1.5, which is our answer in the middle of the zeros. Okay, so that's how we come up with equations for graphs in what we call factored form. Right, this is called factored form, two-bracket method. Okay, now what can we do with these brackets? How can we manipulate? And that leads us to a new little bit here of algebra, which is called expanding. Expanding is just a fancy word for multiplying. So if I want to multiply or expand, if I'm expanding here, these expressions, what's going to happen? So I got 4 multiplied by x plus 1. Now we got to keep in mind that this 4, this is saying 4 x plus 1s. So x plus 1, x plus 1, x plus 1, x plus 1. We have 4 of them all together. So when I'm multiplying, it's not just going to be 4 times x. It's also going to be 4 times 1 as well. We have to distribute. Okay, there's a word here. This is called the distributive property of multiplication. We have to spread out, distribute the 4 amongst the things inside the bracket. So what are we going to get? We're going to get 4 times x, which is 4x, and 4 times 1, which is 4. And we're done. What happens if now it's a negative? So now we're going to have -2 multiplied by 3x, and -2 multiplied by -4. That's going to give us -2 times +3 is -6. And we're just going to have the x from that. And then -2 times -4 is going to be, remember, a negative and a negative make a positive. Remember that trick? How did it work again? If I multiply a positive and a positive, I get positive. If I multiply a negative and a negative, I make positive. And if a negative and a positive make negative, positive, negative make negative. Okay? The opposite signs. If you're multiplying by opposite signs, it's always a negative. If you're multiplying and they're the same sign, it's always positive. One last one. We're going to distribute 3x times x. This is a bit tricky. What happens? So 3 times 1 is just 3. But what's x times x? What's something multiplied by itself? That's squaring, right? So that's going to be x squared. That's tricky here. Oh, I probably have this written down. 1 second. There we go. I have 3x squared, and then 3 times -7 is -21. But I also have the x. So x times, there's nothing there. So we have 1x here. So 1x at the end because of the x at the front, and then x squared because x times x gives us x squared. So careful with those x's. All right. So that's expanding. That's how we multiply out, in this case, a monomial, number in front, times a binomial. Just 2 of them. Now, how do we expand what we call binomials? How do we expand these things that we just looked at, these factored form? How can we rewrite them in a regular way of looking at things? Now, when we do this, we got to be careful. There's a lot of multiplication happening here. Because I have this x, right? X is going to multiply by everything inside the bracket. So x is going to multiply by everything in these guns. And then the 2 is also going to have to multiply by everything inside. If we think about it like this, I have x plus 2. That's the top here. This is x plus 2. Put them together. X plus 2. Oops. Which is my first term. And here I have x plus 1. So I'm going to have to multiply 4 different things. So x times x is going to give me x squared. 2 times x is going to be 2x. X times 1 is going to be x. And then 2 times 2. So notice this is x times x, 2 times x, x times 1, and 1 times 2. Okay, so using this little square here to help us organize all our things. Okay, now this is our answer. We put it all together with pluses in between them because we're adding them all together. So it's going to be x squared plus 2x plus x plus 2. Notice I added them all together, right? Because we're going to have all these things. We're going to multiply all these 4 things and then add them all up. And if we notice, in the middle, x is just x squared. I have nothing. 2. I have just those 2's, but I got x and I get 2x. So altogether, I have 3 of them. So I can rewrite it as x squared plus 3x now, because 2 plus 1 is 3x, and then just plus 2. And that's how I can expand from factored form into what we call standard form. Okay, this is expanding a binomial. And the easiest way to remember this is something called FOIL. Let's say I want to expand this. To remember how to multiply these things, quite straightforward, using the simple acronym FOIL. So we first we multiply the first terms. So x times x. Then we multiply the outside terms, the farthest away one, so x times 1. Then the inside, and then our last. So first, outside, inside, last, FOIL. We're foiling. If anyone ever, a math teacher ever tells you to FOIL something, it means to expand it in this way. Remember, we had 4 different multiplications, 4 different letters. So first, outside, inside, last. Then we add them all together and simplify. Let's try one of these. So we got x minus 3 times x plus 6. So let's do that. Let's multiply. First, outside, inside, last. So that's going to give us x times x, or just x squared. Then we can do x times 6, which is 6x. Negative 3 times x, which is negative 3x. And negative 3 times 6, which is negative 18. Okay? And we just add them all together. We put them all together here. We do all those together. And then last step, we put the x's together. So negative 3 plus 6 is going to give me positive 3. Or final answer, x squared equals 3x minus 18. And that's fully expanded. Now what happens if in B here, the numbers in front are not 1? They have to do the same thing. We still have to multiply. First, outside, inside, last. So 2 times 3 is 6. X times x is x squared. So 2x times 3x is 6x squared. Then we're going to multiply 2x times negative 8. 2 times 8 is negative 16. X times 1, there's a hidden 1 there, it's going to be x. Negative 1 times 3x is negative x. And negative 1 times negative 8 is positive 8. So remember, be careful of your signs. And then last thing we do is we just put those together. So negative 16 subtract 3, negative 19. And we have our final answer. So when I multiply out 2x minus 1 times 3x minus 8, I end up with 6x squared subtract 19x plus 8. Okay? Remember, we have these 4 different multiplications that we have to do. All right, so that's how we expand. So if a question ever asks you to expand and simplify, this is the expanding part where we do our FOIL. Expand means FOIL. And then the simplify part is put the x's together, put the middles together. This is our simplification. I can't spell. This is our simplify part. All right. And that's everything you need to know about expanding binomials. All right. So I know that was a lot. It's a lot of algebra there. Just take your time. Please feel free to ask me any questions on Teams if you get stuck. Go back and watch these examples over and over again if you want. Just keep in mind, right? X times x, some of the things you might forget. X times x is x squared. Okay? Don't forget your x's in the middle. You should always look like this. You should always have an x squared at the front, 2 x terms, and a number. Okay? An x squared term at the front, x terms, and then a number. And the last, right? So, and keep in mind, don't forget the if we're multiplying, a positive times a positive, or a negative times a negative is going to always be positive. But then if the signs are opposite, that's always going to be a negative. So just be careful with that. All right? So, good luck. This is tricky, I know. Please feel free to ask any questions you have. And I'll be talking to you later. Take care, guys.